Imagine you hire 5 workers to finish work faster, but there is one problem. All 5 workers have to share one keyboard, and one can type at a time. The other just wait. Sounds stupid, right? Welcome to the world of Python GIL. Let's imagine a small office. Inside that office, there are workers doing different tasks. Some workers calculating bill, some download files, some call customers. Now in programming language terms, this entire office is called a process, and the workers inside it, they are called threads. A process is like complete office. It has its own room, its own furniture, its own electricity, its own storage. Apps like Chrome, code editors, Spotify all run as a separate process. Now inside one office, multiple workers can exist. These workers are threads, and because they work inside same office, they share everything. Same memory, same files, same resources. This sharing makes thread very fast, because creating a new worker is cheaper than building the entire new office. But the dangerous situation happens. Suppose 2 workers trying to update the same file together. One read the value 10, second worker also read the value 10. Both add 1 to it. Both save the file. Finally, the value becomes 12 instead of 11. Why? Due to data corruption. Python developers face this exact problem. Inside Python, thousands of objects are constantly created and destroyed. List, dictionaries, string, numbers, and Python must carefully track all those things in the memory. If multiple threads changes memory together carelessly, Python can crash, or worse, silently corrupt the data. So here Python introduced a security guard. This guard is called Global Interpreter Lock, or simply GIL. The GIL basically says only one thread can execute Python code at a time. No matter if you create 2 thread, 10 thread or 100 thread, only one gets the keyboard at a time. Now many beginners hear this and get panic. They think, wait, does this mean Python cannot do multitasking? No, this is the biggest misunderstanding. Imagine a restaurant. One chef is cooking, another chef is waiting for vegetables, another chef is waiting for delivery, another chef is washing dishes. Not every worker needs to stop all the time. Similarly, many programs spend most of their time waiting. For example, waiting for internet response, reading files, database query, downloading images, API call. During this waiting period, Python temporarily allows another thread to work, and that is why multithreading works great for input-output based tasks. But now imagine, all chefs suddenly want to stove continuously. Nobody is waiting. Everyone is actively cooking. Chaos. This is what happens in CPU-heavy tasks. Tasks like video rendering, AI training, heavy calculations, image processing, all need constant CPU power. Because of GIL, thread keeps waiting for each other. So multithreading becomes slow over here. So developer found another solution. Instead of creating many workers in one office, they created many offices. This is called multiprocessing. Each process gets its own memory, its own Python interpreter, and importantly, its own GIL. So now multiple CPU cores can truly work together. The simple analogy is, threading is like many workers sharing one kitchen, and multiprocessing is like multiple separate kitchens, called Asyncio. Imagine one super efficient waiter. He takes one order while the food is cooking. Instead of standing idle, he serves another table, then another, then another. One worker's many tasks. Asyncio does not remove GIL, but it simply avoids wasting time. It is designed for tasks that spend time waiting. So, at last, remember this. Threading, many workers sharing one office, good for waiting tasks. Multiprocessing, multiple independent office, best for CPU heavy tasks. Asyncio, one extremely efficient worker perfectly for massive waiting operations. And GIL, it is a security guard. Make sure only one worker touches Python code at a time. So at last, GIL is not a bug. It is not Python being weak. It is simply an engineering trade-off chosen to keep Python stable and memory safe. And once you understand this, Python concurrency suddenly stop feeling magical and start making perfect sense.